Okay, guys, yesterday we had our first day of trigonometry. It might not have made sense. It was fast and furious. So today we get a whole nother day to work on trigonometry. We're going to introduce sine and cosine, and hopefully when we put it all together, it'll make sense how we use trig to solve for missing sides of triangles. Let's take a look at our warm-up. Let's just dive right into it, okay? Oh, that's sweet, Johan. Okay, so what do we do first when we are given a problem where we need to solve for x? First of all, we circle the angle. That's our point of reference. Sometimes people call it the reference angle. Okay, and then compared to our angle, we can label our triangle. X is opposite and 24 is adjacent. And we know that we write tan, we put the angle, then we put equals, and we know the tan ratio is opposite over adjacent. We know the tangent ratio is opposite over adjacent. Then you take a look at where x is. It can be in one of three places. It can be in the numerator, it can be in the denominator, or it can be in the trig function. Hi, Abby. Here, I'll switch. There we go. Woo, that was fun. So, right now, x is in, okay, Lars, we'll do that in a minute. X is in the numerator. When it's in the numerator, we multiply. Make sure you put your 24 first, please. And then make sure that you always keep your angle super glued to your trig function. Never separate the 37 and the tan. Never separate the angle and the trig function. Students like to take it out of the parentheses, but no, it stays there and it's super glued there with the strongest of super glue, okay? All right, so Alexandria, what'd you get for the answer? What is x on number 1? All right, 18.0 actually be 18.09, right? Because that 5 would bump the 8 up. We need to work on our rounding rules. So x would be 18.09 if we were told to round it to the nearest hundredth. Okay, now, number 2 and 3, I'm not asking you to solve anything. I'm not asking you to find angle A. I'm not asking you to find angle B, although you could. I am just asking you for the tangent ratio. Ratio means fraction. So I want you to find the ratio for the tangent of A. So you're really just putting the opposite over the adjacent. Right? Ariana, do number 2, and Dustin, do number 3. Very good, Dustin. The tangent of B is 1/3. We take B and we do opposite divided by adjacent, and then we reduce accordingly. What about you, Lars? Okay, Lars. The answer to number 2 is 3. It's the reciprocal of 1/3. I talked about, maybe you didn't hear me, I was talking about how we're not solving for A, we're not solving for B. I just want to know the tangent of A. I want to know the tangent of B. Here are the answers to that super easy homework. We actually got lazy on this one. We just gave you on-levels homework. We didn't make a whole separate worksheet. We're like, oh, this one works. It's already made. It's in the on-level folder, so we'll just use it. So hopefully it was a very easy intro to our unit. Yeah, Victor, but we did that in the warm-up, so now you know. Okay, yesterday, we only focused on tangent when we were solving for sides of triangles. So we don't have to guess. We know that it's going to be tan. Then we put our angle, and then it equals opposite over adjacent. While you're getting used to it, you can put what I call the skeleton equation. Tan, parentheses, equals blank over blank. Put the skeleton, and you can fill in what goes where. So we know it's going to be tangent because that's the name of this worksheet. It's tangent. Then I want you to circle your angle. Your angle always goes in parentheses every time. Nothing else. Just the angle. Then we learned yesterday, and I hope you wrote in your notes, that tangent is opposite over adjacent. It is opposite over adjacent. You see how x compared to the 50, x is opposite, and 20 is next to, it's adjacent, it's touching the 50. That side is touching the 50-degree angle. Opposite over adjacent. And then We worked on this for a while. We talked about if x is in the numerator, you multiply, denominator divide, and if it's stuck in the tan function, you do inverse tan. In this case, it's in the numerator. That's where x is. So we would multiply. So we would go to our calculator and do 20 times tan, 50. On this next one, you write your skeleton while you're still getting used to it. The only thing ever allowed in parentheses is the angle. You put the angle, and then you put opposite over adjacent. Opposite over adjacent. This one, we are in the same exact boat. It's in the numerator, so we do 12 times tan 34. All we're doing there is we're cross-multiplying. I'm not going through the motions every time. You can put tan 34 over 1, and you can cross-multiply. But now that we know that when it's in the numerator, you multiply, denominator divide, I'm not going through the motions of cross-multiplying every time. But if you forget what to do, you can always fall back on cross-multiplying. Okay? Good. Yeah, someone was saying, did I talk about this yesterday? How I'm famous? I was number 1 on your worksheet. I bet none of you have a trig function as your name. Okay, anyways, it's not. Okay, so remember that there's 3 trig ratios. Sine, cosine, and tangent. Yesterday we focused on tangent, and the tangent ratio was opposite over adjacent. Today we're going to learn what the sine ratio and the cosine ratio are. Go ahead and write these in your notes. The sine ratio is opposite over hypotenuse, and the cosine ratio is adjacent over hypotenuse. Write them down, and then we'll talk about it. Now, this can get really confusing. Tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. How are we going to remember all of this? Well, of course, we're going to need a handy-dandy acronym, aren't we? Let's go to the acronym, and then we'll go back to that one. We're going to need an acronym because it is going to be too confusing to keep track of all of those ratios. So in your notes, really large, write down SOHCAHTOA. Get it? Soaking a toe? Okay, anyways. SOHCAHTOA, write it down. If you can memorize how to spell this, not just how to say it, because if you spell it wrong, it's not going to help you. If you can memorize how to spell this, you will never get confused about trig again, about the order at least. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It goes in perfect order if you spell it right. Okay, anyways. All right, so now we're going to look at a few things. Oh, and this bothers me really quickly. Sorry, this should be X. I'm going to have to change that on each one. Now we're going to have to look at, when I'm given a triangle with a missing side, how do we know which trig function to choose? How do we know? So what I recommend you do is you always start by circling the angle, and then you label the sides that you're working with. I'm working with 18. Well, that is opposite of 27, and X is the hypotenuse of the triangle. So in SOHCAHTOA, which one has an O and an H? Sine, cosine, or tan? Which one has an O and an H? Sine does. So sine the winner? Yep. We would choose sine for this triangle. Next triangle. Really bugs me that one of these is an X, so I'll put X in. Okay. Which one would we choose here? Okay, so we circle our angle, and then we label what we have. 3 is opposite, and X is adjacent. So out of SOHCAHTOA, which one would we choose? Tangent, because T-O-A. TOA stands for tangent. Good job. Okay, let's try the next one. That one was opposite over hypotenuse, so that one was sine. Thank y'all for bearing with us. Okay, which one would you choose? Abby, this one's yours. Okay, ready? Here's what you do. You circle the angle. Then you label what you have. 100 is the hypotenuse. It is nothing else. It is the hypotenuse because it's across from the right angle. What is 70? Is it opposite or is it adjacent? 70 is next to the angle. It's touching the angle, so it's adjacent. I have an A and I have an H. In SOHCAHTOA, which one does that go with? An A and an H goes with cosine. So this one is cosine because I have adjacent and I have hypotenuse. Okay, let's start solving some actual problems. Now that we know how to choose the right function, we can solve the problems. Not yet, Abbas. We got to get through this lesson, okay? So, put this, draw this triangle in your notes. Circle the angle. Label what you have. Adjacent, hypotenuse, C and H. I have a C and an H, so I'm going to choose cosine. And we already learned how to write the equation yesterday. You write the trig function. What goes in parentheses every time, all the time, no matter what? 53, the angle. And then it goes in this order. Adjacent over hypotenuse. Whatever comes first is the numerator. So adjacent over hypotenuse. Once you've set it up, you've done the hard part because everyone knows how to solve it from here. X is in the numerator, so you multiply. So go to your calculator and do 12 times cosine 53. We round to the nearest hundredth. So 7.22. Check your answer to make sure it's reasonable. Okay, 7.22, that's less than 12. It's less than the hypotenuse, so we're in good shape. Let's try another one. Circle your angle. Opposite. Adjacent. So find the one with an O and an A. Tan is our winner. My favorite function. Set up your template. Put the angle in the trig function. And then put opposite over adjacent. X is in the numerator a lot today, isn't it? Okay, so 9 times tan, 29. You should get 4.99, almost 5. So close. Find the value of X. Okay. Circle your angle. Label the sides that you are given to work with. Opposite, hypotenuse. So sine is our winner. Equals opposite over hypotenuse. X is in the denominator. Denominator divide. Please make sure you type 9 into your calculator first. 9 divided by sine 34. 16.09. Hope we're okay with this. Good job. Okay, let's do one where we're looking for the angle. Same strategy. Label what you're given. 17 is opposite my angle. You always look at your reference angle to choose whether it's opposite or adjacent. 17 is opposite of my reference angle, and 25 is the hypotenuse. So I'm going to choose sine again. Sine of X. No, you don't put 17 there. No, you don't put 25 there. You put X there. Opposite over hypotenuse. This is when you need to do inverse sine, which is pressing second sine. 17 divided by 25. And we get 42 oh, we're going to round to the nearest degree. That means whole number. So 43-degree angle. We are finding missing parts of triangles that we could not find earlier. We're finding all sorts of stuff using trig. It's wonderful. Okay, now let's try some little bit more complicated ones. I'm going to give you time to draw this in your notes. Draw the whole picture, please. it's looking like we're going to have to do trig twice. Are you seeing that? We're going to have to find this right here, and then we can find x. So we're going to have a middle step here. The key, what really gets me on these problems is that I need you to keep your middle step, I need you to keep it exact. I don't want you to round and then round. You know how much I hate rounding. Well, with trig, you just can't avoid rounding. And so when you're doing trig and you have multiple steps, you need to keep your whole middle step in your calculator. Keep the whole decimal, all the decimal places. Okay? So let's work with this triangle first. This triangle right here. Let's work with this one. Circle your angle. I'm going to call this y, okay? Circle your angle. 6 is opposite and y is adjacent. So we're going to do tan 39 equals 6 over y. What I don't want you to do is solve for y and then write down the answer to the nearest tenth. I don't want you to do that. We're going to round at the very end. So you can solve for y, but I want you to keep it in your calculator. Denominator divide. 6 divided by tan 39. And I get 7.40938, so on and so forth. I'm going to keep it in my calculator. I'm going to keep it there. Now I'm going to put my calculator down, and I'm going to go look at the other triangle. Take a look at this triangle. Circle your angle. Compared to 46, y is now opposite, and x is the hypotenuse. So I would write sine of 46 equals y over x. X is what we're looking for. Denominator divide. So we're going to keep that number in our calculator, whatever y was, and we're going to divide it by sine 46. Does that make sense? If this answer is sitting in your calculator, you can just press divided by, it'll take your answer, divided by sine 46. And that'll get us the most exact answer that we can come up with. I don't think you can see that very well, but the glare. It takes your answer and you just divide it by sine 46. So anyways, you should get 10.3. You getting 10.3? Moral of the story is if you can avoid it, don't round as you go, because that'll get your final answer further and further from the real thing. Okay? All right. I think we have, how many more? One. Yep, one more. Last problem of the day. Round x to the nearest whole number because it is an angle. I'm going to give you a little bit of time to think about it before I start blabbing. Take a look at the big triangle. If you could find angle y, how easy would it be to find angle x? That's the most direct way to solve this, guys. If you're finding the hypotenuse, if you're finding that other missing angle, that's fine, but you're just definitely doing too much work. So, let's find angle y. Tan of y equals opposite over adjacent. Second tan, 7 divided by 16. Angle y to the nearest whole number is 24 degrees. Wow, that was easy. 180 minus 24 minus 20. 136. And we solved that problem in under a minute. How did y'all do it? You started to find the hypotenuse. You didn't round, did you? 7 squared plus 16 squared. So the hypotenuse is the square root of 305. You didn't round that answer, did you? I'm not sure that would help you, though, to find the hypotenuse. The key to this problem, the moral of the story, is you can only use trig with right triangles. So when I give you a problem that has multiple steps, you need to start with a right triangle to use trig. Don't try to use trig on that obtuse triangle with the 20 and the x and the y, okay? Yeah, you can't use many trig functions in this picture because you can only use it on right triangles. So you could have only used it on the purple triangle, or you could have used it on this yellow triangle, except you didn't really have enough information to use trig on the yellow triangle. Okay? That's it. That's the end of the lesson. Please make sure you do the homework called trig practice over the long weekend, since y'all get a long weekend. We don't. And I will see y'all on Tuesday.